Okay, let's talk a little bit about ammeters and voltmeters. These are devices we've already used before, but now we really want to be formal about the way that they're supposed to be connected and what's happening internally inside of them. How do they affect the circuit? Because if they have resistance, then they will affect the circuit. And ideally, when we use measuring devices, we would like the measuring device to not interfere with the thing that we're measuring. So that's where, for example, when we use the ticker timers, of course they interfere with the device because they're literally physically taped to the device and the piece of paper must be pulled through the timer. So they do affect it. Whereas if, for example, we were trying to time one of those vehicles with a stopwatch, we wouldn't have to interfere with the vehicle. So to that extent, we would not be providing any resistance to the vehicle where the ticker timer does. So we don't want to interfere with the circuit too much. And obviously there are only two devices we're talking about here. So there's the ammeter and the voltmeter. And I'll draw them in a circuit down below here in just a moment. We've already seen how to use these devices because we practiced with them in the labs, making the measurements. I think that conceptually, though, it would help for you to just think about what it is that it's doing and what the measurement that it needs to make in order to know these values, to know what the current is and to know what the voltage is in a circuit. It needs to somehow be able to interact with the circuit. Now, when you think about the current, which is what the ammeter is going to measure, that is very much like a turnstile at like an amusement park. You really need to be in the way of the particles, whether it's people or electrons or molecules of water, whatever it is. You need to be in the way and interact with them to know that they're there, to know that they exist, to sense that there's something there. And so the ammeter essentially has to be connected in series. It has to be connected in series, and it's going to be in the way of the charges. The charges have to pass through the ammeter from whatever the device you're trying to measure. The charges must pass through the ammeter and through that device that you're trying to measure. So that means that the ammeter is interfering and actually maybe changing the circuit because it's in the way. So for that reason, obviously what we would really like the ammeter to do is to have very low resistance. How low, really depends on the quality of the ammeter. Very cheap ones, probably not that low, maybe only 0.1 ohm. But really good ones might get down to 1,000th of an ohm or even less. And so essentially what they're doing is they are interacting because, again, they must interact in order to count the number of things going by. You have to interact with them somehow. So in that case, they are interacting with them, but it's such a low level that it's actually not changing the reading on the ammeter. Right? And that's like a weird thing. The ammeter could affect its own reading by adding resistance to the circuit. So that when you connect the ammeter, that's not the real current that was passing through it. That's the current that's passing through it when the ammeter is connected. So the ammeters have very low resistance, and the better the ammeter that you have, the better the lower the resistance is going to be. But ideally, if we could get the resistance to be like, let's say, perfect, so that it did not affect the circuit whatsoever, then obviously we would want to have zero resistance. That's not really feasible, but if we can get very close to zero, then the influence will be so low that the ammeter won't even be able to tell the difference. So let's say, for example, the current is 0.45 amps. Well, if when we connect the ammeter, it lowers it down to 0.449999, that's a slight change, but it's not really significant. And what is the ammeter going to show? It's going to say 0.45 because it can't even show those decimals. So 0.449999 is 0.45, and that's what the ammeter is going to read. So we want the ammeter's resistance to be so low that it's below the level of the ability for the ammeter to even pick up what it's doing. That's going to be the best that we can do. That's the most reliable thing. Now, the voltmeter, on the other hand, is completely the opposite, as you might expect. And virtually everything we've been doing with since we started with electrostatic charge is always about these things that are opposites, always behaving in opposite ways. The voltmeter is not trying to count anybody. What the voltmeter is trying to measure is how excited are the electrons as they pass by. Now, it does not need to get in the way in order to be able to do that. Like, imagine you were standing at Great America and you're watching people go in. Wouldn't you be able to tell who was excited and who was not excited by just simply observing them from the side? Or let's imagine this. Let's say that you have a water pipe, okay, and there's water flowing through it, and you know that the pressure at the top is not as great as the pressure at the bottom, you don't have to get inside the pipe in order to know what the pressure is in there. So we could simply drill a hole in the bottom and cover it up with our thumb, and then drill a hole up near the top of the pipe and cover that with our thumb, and they will feel different. Even I'm not restricting the motion of the water, but I can feel that the pressure at one point is more than the pressure at another point. And if I had a way of measuring that, like let's say put something there that could measure the pressure, I could just subtract the two and I would get the pressure difference. And that's exactly what the voltmeter is doing. It doesn't want any of the current to go through it. It just needs to touch that wire in two spots, and it will pick up if there's a difference in the level of excitement of the charges. So for that reason, we connect the voltmeter in parallel. And since we've now created a new path, right, by connecting something in parallel, that means you have created a second path that would allow you to go around that section of the circuit. For that reason, we want the resistance to be very high. So by doing that, that will prevent any current from going down there, because again, if we allow any current to go down that voltmeter, then the circuit that we're measuring is not the same as the circuit would be if we took those measuring devices out. And I don't want the measuring devices to cause the circuit to behave in a different way, so that what I'm getting is not really what the circuit would be doing if I didn't have those voltmeters and ammeters connected to it. Now, how high is high? I mean, a cheap ammeter is probably going to still be at least 30,000 ohms on the voltmeter, but could be 50, 100,000, 300,000 even. Could be very high resistance on those. And that's going to prevent not no current from going down there, but it's going to prevent, almost all of the current from going down there. Very, very tiny amount. An amount that's so small that, again, the ammeter would not even be able to pick it up. If you just play that out to its extreme, what would be the best possible situation? Well, that would be if we had infinite resistance. So with infinite resistance, no current would go down there. There'd be no effect on the circuit, and we would get the voltage of the thing that we were connecting it to. And let's go ahead and draw a simple circuit so we can just see these two guys in action. So what I would do normally is I would put the ammeter near the battery. I would like to know what's coming out of the battery. And then over here we can put a light bulb. Okay, so that's how the ammeter should be connected. This guy is going to be connected in series. So I've completed the circuit. The circuit is now functional. I don't need the voltmeter for this circuit to work. Okay, but I do need the ammeter to be in there. Otherwise, I can't get the current. I'd have to disconnect it, put the ammeter in. So the ammeter must be there. Now the voltmeter should be here. And that's only if I want to know the voltage on this guy. Now I'm drawing it as though I'm connecting it, but if you've noticed what we do with the voltmeter, we don't connect it to the circuit. We don't connect it. We just touch the circuit. I touch on one side of the device. I touch on the other side. The voltmeter will pick up that there's a difference in the energy level of those charges that are passing through, and it'll tell you what the difference was. It'll tell you if it's a 1 volt or 2 volt or 3 volt difference between when it touched on this side to how excited the charges were when they got on this side. I'm sorry, I didn't even draw the voltmeter. My apologies. I didn't even draw the voltmeter in there. And so that's essentially how the device works. Now, one last thing before we leave the voltmeter. The reason why the voltmeter tells you the voltage on this portion is because of the rules for parallel circuits. The rule in parallel is that both these guys will have the same voltage. Okay, because going from this point right here, whether I go through the voltmeter and arrive here or whether I go through here, I must drop down to the same level. Because look, once I go past this point, if I am not at the same level, if this guy's not lowering the energy level by the same amount as this one, then that means that there's going to be leftover energy. So that means that all the energy was not dissipated. And somehow the charges still have energy when they return back to the battery. So when they leave the next time, after they pass through and they're re-energized, they'll have even more energy than the first time that they left. And somehow we will be magically creating energy out of nothing. So the idea behind why the voltmeter reads the voltage is because any two things that are in parallel with each other must have the same voltage. I mean, that's just the reality. It must work that way. And so what essentially the voltmeter is really doing is measuring its own voltage, but that voltage is the same as the voltage on the battery. So that's why this guy needs to be put in parallel. And that's all you really need to know about the voltmeters and the ammeters.